let's continue with our next presentation. Our next presentation tries to include some of the key issues to take into account in a strategy to implement metrology for Industry 4.0. In the task force, Metrology for Industry 4.0 have been working with our colleagues from the SIM, and we are trying to do a guide or compendium of experiences, capabilities, as well as recommendations in order to maybe have a strategy or a pathway to get to reach to metrology for Industry 4.0. Industry 4.0. So the next presentation is going to talk about it, and our next presenter is our colleague from Senam, Mexico. The title of this presentation is a strategy for the implementation of Industry 4.0 by Aldo Garcia from Senam. And Aldo Garcia has experience in development of projects and services for the area of vibration and acoustics of Senam, knowledge applied to vibration and acoustic measurement, experience in calibration services, development and optimization of measurement systems using instrumentation and signal control of various transducers, as well as programming skills, knowledge of standards for measurement laboratories, uncertainty estimation, teamwork, continuous improvement, and implementation of agile models. He has an active participation in digital transformation topics such as Industry 4.0, Metrology 4.0, digital calibration certificates, remote sensors, and metrological cloud. He currently leads one of the digital transformation task force under the name of Agile Project. So welcome, Aldo. I'm going to participate with him in the presentation, but Aldo, please start and go ahead with the presentation.
Thank you very much, Gabriel. Thank you for all of our participants here in this meeting. As Gabriel said, I'm going to talk about a strategy for the implementation of Industry 4.0 or zero through digital transformation. And this topic is very interesting because, as Gabriel says, we developed this presentation with all our experience, and we want to begin this meeting and this talk with this slide because we want to let you know which is the digital transformation goal and understand the process to achieve the digital transformation. This is very important because if we want to impact to the Industry 4.0, we need to pass through these different stages of digitalization. So you can see we initialize in our NMIs. We need to make a scope of which stage in which stage is our NMI. So we start from the digitize information. Is only put the information in a digital way. We are not using it for any process. It's only for storage of information. Then we use the digitalization to integrate this in a process. So maybe we can see here this first stage of digitization, like the PDF, digital calibration certificate. But if we are going to use to the next step of digitalization, maybe we are thinking in another kind of focus, like use the information between computers to introduce this information in a process. So this is the automate process and streamline processes. We need to use digitalize data in order to put into a process and take advantage of this information that is stored in our databases. So the next step is the digital transformation, and in here we communicate not only processes, we are communicating organizations, we are communicating different product lines, we are communicating a lot of information through different stages in the organizations and between organizations. So in this final step, we see the true shape of the digital transformation opportunities. So we need to understand if we are an enterprise, organization, or an NMI, we need to know very well in which stage we are. So this is an explanation of the different stages that we are thinking on, and in which we are. We need to know in which we are. Sorry. So regarding the metrology, we thought this is a good way to express in a sentence the digital transformation in metrology. So we say that it's the usage of computers, instruments, IT technologies to automate and optimize a process through the exchange of standardized data between machines in order to give traceability among the metrology value chain. So this is we mix different definitions of digital transformation, of metrology, and we converge those ideas in a few words. So if you can see here, I am showing you how is this process, how we use the traceability, and how we are going to use meta languages to use this information, not only to storage. We need to share the information between organizations. So we need to pass through this firewall, if you want to make an analogy, firewall between the NMI of secondary laboratory or so on. The people that are given the traceability from calibrations to our users, final users, can be the industry, for example, or the government, and there is a lot of possibilities here. So we need to share this information to be used in different process. So this is why we need to digitalize the systems, because we need to share this information. We need also to talk one only language, or make the effort to give this information in only one or kind of language, because if we want to take advantage of this interaction between processes and organizations, we need to talk one language. So that's why meta languages can be this answer. So if you can see in a transversal way, we have the digital transformation. So this is in order to let you know and you focus your effort to understand our vision of how is the digital transformation in metrology. So we are thinking in take the we need to define the strategy. So that's why we are agree. We're thinking that it's a good way to share information in a standardized way, from the use of the XML for digital calibration certificates. And we want to share with you this slide that this comes from the PTV, only to let you know the different levels that are included to have the utility model of the digital transformation using the DCC. So the first stage, as you know, is the paper. We use the paper to communicate, to inform, to let the user the information about the calibration, and this was useful for them, maybe for accreditation topics or something like that, but not for maybe for introduce it to a very complex system, to be, because it's not, the timing is different, so there is no real time in the sharing of the information. So that's why some industries are still doing this in this level. And then we go to the digital document. This is a PDF only for let the user to let to share the information to the user and maybe storage the information. The level 2 is machine readable document. So here we can share between machines the information, but at the level 3, the machine can make some processes, very basic processes like understand the information, maybe extract some kind of information. But in the level 4, we are interpreting the information. We have good practices there, and we can be more flexible about the uses of this information to impact different processes and or organizations. And the final one is the machine controllable contents. We are saying about digital twins or applying intelligent artificial intelligence. Maybe we want to read different documents and extract information and have a better way to use this information in a very automated way. So the level 5 is our goal. So this is important to you know this because we think this is the proper way to do it. Uh, as a personal comment, for sure. And here I'm going to give the word to our colleague Gabriel. Please, Gabriel.
Thank you, Aldo. Yes, as I mentioned before, the idea of this presentation is to show, to put for your consideration this step of the strategy. We call the strategy, but we are building these steps in order to get the implementation of the Metrology for Industry 4.0. We already know that in general terms, the Industry 4.0 use many tools, technology tools, and there is a tool that integrate different key topics, and there are many tools. I show in this slide just one that was performed in Germany. But the idea is, but when you see this type of tools, you don't see metrology. So as you can see in this general self-check for Industry 4.0, they talk about employees, strategy and organization, smart factory, where the metrology is included, but not explicit. The smart operation, smart products, and data-driven services, and then other subtopics. And then this tool in particular, it depends of the auto evaluation, identify if the industry is in newcomer, learner, or leaders. So the idea is as well for the next step, next slide, please. In the task force, we develop a simple Excel file in order to know where is our NMI or lab on the road to the metrology for Industry 4.0. So the idea is where we are and to make about the diagnostic. We consider 11 key elements. One of them is that the NMI of lab has a M4DT strategy. The other one, and some of them has mentioned by our previous colleagues. I remember that Nordman mentioned that the LCM has a structure that has personal, but it's very necessary to have a different kind of expertises. So the organizational structure, as well the automated processes is another key element. Marcos mentioned the DCC, Digital Calibration Certificate, is one is the ideal capability in order to introduce to Industry 4.0, as well as cybersecurity, the communication is very important as well. The systems and programs is another key element. The use of the cloud, to use a cloud computing, and other key element that we consider in this tool is the consulting to industry. As someone mentioned that they have this industrial linkage strategy. in order to get closer with the industry. The other key element is that we already have clients, customers for Industry 4.0 in order to make or to do new services that attend the needs of the industry. And the other is the technology as well. The phone, in the case of example that Marcos showed us, but he mentioned that the project was founded by other institutions. Okay. Next one, please, Aldo. Is your turn. Go ahead.
Yeah, thank you. Yes, it's very important, the comments that Gabriel gave us. So that's why we are suggesting to implement a TRL plus digital transformation surveys or analysis in order to implement the metrology for Industry 4.0. So we can see this a very typical or general TRL, that is technological readiness level. So there are nine stages. Maybe you can understand this if I can explain it further, this information. So in the stage 0, we have the first principles. We are going to define in our NMI, which is the strategy that we are going to implement in order to achieve the Industry 4.0. So if you can see in the right side of the slide, I place a very complex, if you can see, diagram in order to explain better these ideas. This is because you can see different colors, and we are trying to explain the different stages to understand if the NMI can be prepared or can participate in order to have this interaction with the Industry 4.0. So the first thing that we suggest, I'm going to explain this first, and then I'm going to relate the TRL structure, is we are going to reunite with our NMI. We know that our core is at metrology. Our core of the NMIs are metrology. We know very well that we need to implement another kind of skills like programming and developing of electronical devices and so on. But at our core of the NMI is metrology. So we need to take advantage of this. We need to have a reunion with our NMI directors, and we need to understand and make the question, what is the Industry 4.0 for our NMI? We need to answer this question first. Then we need to ask to the different areas or departments or silos of NMI, for example, mechanics, electric, materials, chemistry, physics. Those different areas, we need to ask them their capabilities and the services that they are providing, and if they are interested in collaborate to develop a tool or develop a solution that can be impacted in the Industry 4.0. So those different areas need to understand, need to share this information. For example, the different departments from, for example, mechanics. This is an example. Maybe dimensional wants to share something to impact to the Industry 4.0. Maybe they have a methodology, developed methodology, a test bench to impact in the industry. So first, every time I want to say it, first is the metrological core. Here is only metrological core. So then in this step, when every area has identified the capabilities or services that can be impact to the Industry 4.0, we are going to have this interaction with task force in the NMI. Maybe you are achieving the goals to develop digital transformation in your NMI. So we need to merge the core of metrology and the core of digital transformation, and they are going to collaborate. So first, we identify the capabilities of every area to impact at metrology 4. The industry 4.0, and then we are going to go with the digital transformation team in order to add this other kind of skills like programming and developing of electronical devices and so on, integration. And in this way, we are going to complete this synergy between the core of metrology and the digital transformation. And we are going to prepare a user case. We need to prepare a user case. We need to invest in order to develop a solution that can impact to the industry 4.0. So then we are going to select this. For example, we select one capability from temperature, and we are thinking to impact to the industry, maybe in a thermographic chamber. And in this way, we are going to have an implementation to the temperature laboratory. Here we are going to share, and we are going to share the information maybe between digital calibration certificates, maybe giving them the solution, applying methodology, and always merging the core of metrology and the digital transformation. And in this way, we are thinking that we can impact to the industry 4.0 in a very well-known form to implement our core, metrological core, with the digital transformation core. So we need to implement these different stages of the TRL in order to implement and deploy these different capabilities from our metrology course and areas. So this is a pathway to implement M4I 4.0 that our colleague Gabriel going to explain. Go ahead, please, Gabriel.
Thank you. I think there's nothing more to explain. This is a summary that you already said. So please, I suggest to change the slide, please. The next one, this slide tries to show maybe the type of approaching. As you said, Aldo, there are a way to do in order to implement in the NMI metrology for industry 4.0. In this slide, in the left side, there are some activities, functions that that are in red, that it can be our strengths, because there are activities or technologies that most of the NMIs have. So in the yellow letters are the activities that are implementing already. As well, some of them are mentioned in this event, and the other ones are in the green color are the activities and technologies that the NMI has to implement in the near future. As well, we have to know our strengths, our weaknesses, but as well, it's very important to be very close to the industry 4.0 and to know what they are doing now. In the case of the right side, some of activities that already do the industry, but it's automation like SCADA, for example. They have a sensor network. They did 3D manufacturing, robots and cobots, digital twins, and they are going to advance on sustainable manufacturing, and as well as as Olman said at the beginning, to work in the internet industrial of the things, as well cybersecurity, big data, and then machine learning and augmented reality. The idea is to, as a NMI, to be aligned to know those kind of needs in order to meet the digital needs and challenges. And we know that all of our NMIs and labs and bureaus has industry to services to industry, some technical assistance services like Foreman said that they have a heavy tool. In Mexico, we have a Mesura, and we are trying to 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 improve our methodology in order to to meet the digital needs to the industry as well. As well as Marcos mentioned, it's very necessary to have strategic alliances to make that kind of alliances, and as well projects and close collaboration, win to win and learn to learn. And Mexico, we have one project as well as the BCC with automotive industry. The idea is to work in both sides, push by the NMI with our expertise, our capabilities, and our offer. And the other side is to take into account and to attend the industry, what the industry is interested in metrology. So this is more or less one idea of this approaching to Industry 4.0, seen from the metrology. Next one, please. Some concluding remarks. I don't know if you want to mention, Aldo, please.
Yes, thank you. The final conclusions are that we need to share NMI experiences, capabilities, and learnings in Industry 4.0. We need to merge different skills. That's why we say that it's a multidisciplinary development. We need to focus on developments that can be replicated to more services and not just to one. This is a very important thing. Focus on services that can impact users and explore different types of industry, agro, food, pharma, energy, and so on. And we need to close collaboration with communications and information technologies to developers and SMEs. Yeah.
Small and medium enterprises.
Yes. Okay. So thank you very much for my side, and for sure from the side of Gabriel for this time. And if you have some questions and comments, suggestions, please let us know. Thank you.
Thank you very much, Aldo. And we have a question, and Roberto Benitez, please go ahead with your question, comment, please. We can hear you. Okay.
Hello, how are you? I have a question regarding to the work that, in this case, Senam is doing in the digitalization. From your point of view, what do you know, or what do you consider is the final user of the digital calibration certificates? Would be the plant or the industry that is on the field, or the secondary laboratories? Because as I know, the final process of the calibration is the instrument that is installed in the process or in the final measurements. What will be your customers, like an NMI, the industry or the secondary laboratories?
Go ahead, Aldo.
Yeah, thank you. For sure, we are giving the usage of the DCC not only for industry, not only for laboratories, secondary laboratories. They are open to those that needs to use this digital calibration certificate information into their process. We are seeing that for sure in more or less 2 or 3 years, the secondary laboratories must to go through the digital transformation topics and developments in order to implement digital calibration certificates, because we are seeing and we are advising that in some few years the industry and the government and so on will need this kind of information to put it in their processes. Right
Okay.
now, maybe it's not a necessity because we are developing right now this. We are in how do you say? We are in parallel with our colleagues in Europe developing this digital calibration certificate. So that's why we are seeing that in 2 or 3 years we are going to need to spread this DCC to our users, like secondary laboratories in industry, government, different economical activities. So that's the answer. I don't know, Gabriel, if you want to say something else.
Thank you, Aldo. Yes, me note what the Carlos Galvan, our colleague Carlos Galvan, has write in the chat that DCC user, as well as for industry, is for all entities in the quality infrastructure. So I don't know if Marcos Verstude would like to comment something.
Yes, hello, how are you? It's difficult, I think, trying to understand the final impact of the DCC. We are discussing here a lot about that. Some way I think that it will be very interesting in some applications. In others, I think that perhaps not. This is my interpretation now. So I don't really believe that we have to be implementing the DCC. We have to, as recently say, to see that this is something that is in process, that will need some time to reach a stable state. And we have to start to show experience and apply the DCC where we really believe that it's important. For example, when you have a lot of data, of calibration data. In that case, it's very important. And in that case, we have a trend that is useful right now, nowadays, which is the calibration of the vector network analyzer. They produce, it's not a DCC format like PTV. This format was produced by Metas of Switzerland. And this is a format that is used here in India and many other countries. And the great advantage of this is that the Metas also develops a software to understand the XML file and calculate all the uncertainty for the use of the vector network analyzer. That is an example of something really useful, but I don't know if we're going to have this experience in the same way in all the areas. I really believe that the DCC will start to be useful and very useful in some application. A lot of data. Oh, yes.
No, go ahead.
No. I think that there are two areas, or a lot of data, or where you have a software that control all the process, no, like in IoT. No more.
Thank you, Marco. I'm going to just clarify that yes, it's important your comments, and that's why we said in this presentation that the NMI must define. In these slides, we are showing about the Industry 4.0 and our suggestion. This is a work in progress, as Gabriel said, and that's why each NMI must to meet with the different areas inside of those NMIs and discuss in that moment for them, in that case for the DCC, what is the goal of the DCC. And I think you made this analysis with your NMI. That's great. And that is a very big step that most of the NMIs must take. Understand which is the path of the NMI regarding for that case the DCC. In this case, is the Industry 4.0. Yes, and that's why we understand that maybe these are different the scope right now regarding those topics. But you can see each NMI must have these meetings in order to define which is the path that they are going to go through.
Okay.
And this is because they have different industry situation, different economical situation, different political situations. So that's why each NMI must converge in a meeting to discuss these topics. This is only to go with the analogic part of this presentation.